Hi everyone, so in this video we're going to go ahead and talk about the life cycle of stars. So just like humans undergo changes as they grow and get older, so do stars. Okay, so stars have different distinct phases. We say that they're born when they start to create nuclear fusion. They also develop and then eventually they do die. So stars will change throughout the different parts of their life, just like humans do. So as we go from being an infant to a child to an adolescent and then an adult, humans change. The same thing happens with stars. And the pathway that a star follows depends upon its mass. So really high mass, large stars will have a different pathway from ones that are lower or medium in mass. However, all stars start out with the same initial path. So let's go ahead and talk about that first. Okay, so all stars begin as a nebula, which is really gorgeous if you ever see pictures of them. And nebula actually comes from words which mean cloud or gas. So we have a cloud of gas and dust in outer space. Eventually, this cloud starts to come into the middle, kind of sucking into one tight spot, collapses in on itself, and it starts to spin around faster and faster and faster. As this happens, we have a stage known as a protostar, meaning almost a star. As the core of the protostar continues to get closer and closer together and spin faster, it gets hotter. So this is what allows nuclear fusion to start to occur. And nuclear fusion is when two small, simple atoms combine to give us one more complex atom. So in this stage, hydrogen, which is our smallest element, is going to combine with another hydrogen atom to become helium, which is the second smallest element. So when we are starting to get this helium formation occurring, the star has officially become born, quote unquote, and it is known as a main sequence star. So from here, things change whether we have a low mass or a high mass star. So for stars with low to medium mass, and this includes stars like our sun, the next stage is they kind of hang out as a star for a while, but eventually they're going to run out of that hydrogen. They run out of that fuel. And when this happens, they start to cool down. So this causes the core of the star to contract upon itself, kind of suck in and get small little dots in the middle. So when this happens, we have the core getting tighter, which causes it to heat up. But the outer shell starts to expand, and this is when it forms something called a red giant. So they literally change color to become red and larger. Now, red giants are larger than the original star, but overall they are cooler. Okay, so they cool down. That's what the red color is telling us. And in red giants, they're going to combine helium, that smallest element, second smallest element, into carbon. Okay, so again, we still have atoms combining together to form new elements, but in this case, we're forming something a little bit bigger, which is carbon. Now, eventually, the red giant is going to run out of helium, just like the original star ran out of hydrogen. When this happens, again, the core collapses in on itself. And this time, the outer layers of the star are expelled. So they move out, spread out, and the outer layers form a planetary nebula. Okay, so we have that gas, and the core, what was left over from the red giant, becomes a white dwarf star. So white dwarf stars can no longer undergo nuclear fusion. So we're not creating any new elements, and over time, they're going to cool off. As they cool down, eventually they're going to become black dwarf stars. And they're just kind of hanging out in outer space. They're not going to have that energy exchange going on anymore. Okay, so now let's go ahead and talk about high mass stars. So similar things happen. Just like that low mass star, eventually they run out of hydrogen and they start to cool down. At this point in time, the core contracts, and that causes the core to get hotter. Meanwhile, the outer shell of that star is going to expand, this time forming a supergiant. And this is going to be even bigger than that red giant that we had with those smaller stars. Those supergiants are absolutely massive stars. And they're going to go through changes much faster because they're going to burn up their fuel really, really fast. So they have very hot cores, and they have nuclear fusion still going on, but this time we can create heavier elements, bigger elements. So the small stars can only get up to carbon. Supergiant stars, because they're so much hotter, can get all the way up to iron, which is much, much bigger than carbon is. And eventually, just like those smaller stars, supergiants will run out of fuel. When this happens, like the small stars, the core collapses, but in this case, we get a supernova as that outer shell is expanding out. Now, after the supernova, we have one of two cases that happens. If it's a smaller, large star that's left over, we get something known as a neutron star. If it's 1.4 to 3 times as large as our sun, we get a neutron star. However, if we have a lot of matter left over from that supernova, so 3 times the amount of stuff we have in our sun, this creates a black hole. And black holes, you've probably heard a lot about them, are really cool. So they are large, and very, very dense. I mean, there's a lot of stuff packed into a small area. As a result, they have a very strong gravitational pull. They're going to pull everything around them into them. And this gravitational pull is so strong, it even prevents light from escaping from the black hole. Because light cannot escape, we cannot detect black holes directly. Instead, we have to look for their impact on other surrounding objects in order to know if they're there. Okay, so I hope this helps clarify some of the differences between smaller, low or medium mass stars and high mass stars. Otherwise, remember, all stars start off with the same process. So they have the nebula, which becomes the protostar, and then the regular star converting hydrogen into helium. And then otherwise, all stars have a life cycle. They are born, they change, and then eventually they all use up their energy and their fuel, and they die. So if you have any questions on this, please go ahead and let me know. Otherwise, have a great day, everyone. Bye.